Welcome to part 4 of the best way to learn Python tutorial series. Today we're going to look at slicing, string interpolation, list comprehension, the Zen of Python, and we're going to be writing a little weather app, something that will kind of retrieve the weather forecast from API and display that in a graph to try and demonstrate all the things that we've learned today. Okay, as per usual, we start up the Anaconda IPython Notebook. If you're on Windows, you can just run IPython Notebook --pylab equals inline. Under Linux, you can activate the environment, but it also works if you simply run IPython from the Anaconda bin directory. You can do the same in Windows, but there it's usually in your path. So you don't even have to specify that Anaconda bin that I'm doing now. So I do IPython Notebook pylab equals inline. So this will give us our IPython notebook dashboard. So let's create that new notebook for part 4. And let's get started. So first things first, as per usual, we do from future import print function. And you'll recall that I showed you last time that 4 divided by 3 in Python 2 gives you an integer division unless you cast it explicitly to float. That's also a little difference between Python 2.7 and Python 3, but I can change my Python 2.7 with another one of these future behaviors by importing division. And now when I do this, I'll get a floating point in any case, regardless of my casting. So that's the way Python 3 behaves, and that's quite a significant difference between Python 2.7 and Python 3. Okay, then there was something very important that I wanted to show you, and that is the Zen of Python. So whenever you're at any Python interpreter and you type import this, so I'm doing Control Enter here to run that, you get the Zen of Python, written by one of the Python luminaries, Tim Peters. Read this when you have some time, focus on it. There are they're all good philosophical points that you should really take to heart. Things like simple is better than complex, explicit is better than implicit. And then my favorite, although there should be one and preferably only one obvious way to do it, although that way may not be obvious at first unless you're Dutch. But the general idea behind this is the same, is that usually in Python there's one good way or one right way of doing anything. So read this whenever you have time, or when you're taking a break, type import this at any Python interpreter to, absorb more of the Python philosophy. Okay, so today I wanted to show you briefly about slicing, about list slicing. This is a really powerful way to slice and dice Python lists and tuples. So let's just make ourselves a list to work with. So here, by using range, remember it starts at the start number, which by default is 0, and it always stops right before the stop number. So that gives me the sequence that I expect. Okay, now let's go and make up a new cell. And as you know, I can now index this like that. So this will give me the third element. So it's 0 based. So that's 0, 1, 2. Coincidentally, that's also the element 2, which makes it convenient. And then things start getting interesting when I use negative indices. So this in Python is a shortcut for give me the last element, give me the second to last element, give me the third to last element, and so forth. So I can also count backwards in my lists. It becomes even more fun when I start using multiple indices. Then it's not called indexing anymore, it's called slicing. So now, for example, I can say give me all elements starting from the second one, 0 base, so that's actually the third element, and going right up to before the fourth index. So that's as I explained with the for loops, Python always includes the start number and it excludes the stop number. So in this case, I'm going from the second, or at least element with index 2, so that's 0, 1, 2, that's number 2 over here. It's going to give me 3 as well, but it's not going to give me 4 as I expect. Have a look. So I'm only getting 2 elements. Remember, it's always skipping that last element. I can make it even more interesting by using the stride. So I can, for example, go from element 2 to element 5 with a stride of 2. So now it's starting at 2 and it's stopping just before 5, and it's skipping elements every time. So it's not usually, like it's usually by default it's counting obviously one element at a time. But now I can tell her to count in 2s or to count in 3s, which is quite convenient. Okay, what's also interesting is that there's a shorthand for skipping the start or the end if you want everything. So for example, I can go from the second element to the end of the list. So that means I specify 2, and I just don't specify the stop element. Or I can go and say, well, give me up to the last element. Let's say up to the third last element. Because I skipped the start number, it gives me everything from the start of the list up to my stop number. I can also go and specify, just as I did with range, I can specify a negative stride. So for example, I can say, let's go from the last element to the second element from the start and count backwards. So look, so that's a way of, very nice way of swapping around or reversing my whole list. What's a nice shorthand here is if I just want to reverse version of my list, I don't specify the start, I don't specify the stop, and I just specify the negative stride. And I get my whole list back, but I get it in reverse sequence. So this kind of notation is actually quite useful. I can do even more with it. I can, for example, make a new list. Let's call that B. Let's put it in a different range just to differentiate it from A. And now I can, for example, do replace the second to the element with index 1 up to just before the element with index 5, and replace that whole subslice, replace it with this new sequence. And look what it does. So I had my nice 0 to 9 list A, and now I've gone and I've sliced out 1 to 5 and replace it with my new list B, which goes from 11 to 14, as you can see over here. So you can see this is quite a powerful way to manipulate lists of all kinds. Okay, so this also works for strings. Because a string in Python is nothing more than a list. So for example, I can use that same shorthand specification and I get my string flipped around. I can also obviously index out any specific character. So it's seeing this string, it's seeing as a long list with each character being a separate element. Okay. Now it becomes, there's another construct I'd like to show you called a list comprehension. So a list comprehension is a very compact way of applying an operation to every element of the list that you would usually use a for loop for. You can now pack that whole for loop and the operation you can pack into a single statement. So let's try that, and I'll show you something else in the process. Now that's the split method of any string object. So by default, split goes and it separates out the based on by default the space delimiter. It separates out the groups of letters. So in this case, because space is the default, I now get out the words. So I might as well just call that words. Okay, and now to show you what a list comprehension could do, I can, for example, go so that's a list comprehension. What's happening here is that it's executing actually this for loop for word in words. So it'll iterate through the whole of words, which is each word in the sentence. And at each and every iteration, it first checks if the letter O occurs in that word. And if it does, it returns word. I can make it a little more interesting by, for example, uppercasing that word. So in this case, it's doing exactly the same. It's iterating through the whole list. It's checking if O occurs in that word, and if it does, It returns it, but the uppercase version. So that's a list comprehension. It's a really compact way of applying an operation to all elements of a list. Okay, I also said that we would look at string interpolation. These are all things basic concepts that we need to know before we can continue. They're all quite useful. You will hopefully soon see. Let's say, for example, that I would like to write a function that's able to output a string, but where I can substitute other animals for fox and dog. So I want a more generic way of saying the quick brown fox jumps over the lazy dog. So what I can do is I go the quick brown and replace fox with a %s, which means it will be replaced by a string, jumps over the lazy, and another string. And then a string interpolation that works also with a percentage sign, and it wants a tuple of variables that it'll use to fill in those placeholders. So in this case, let's just do what it usually does. So there you go. But the nice thing here is I can now go and replace fox by crocodile, for example, and it'll nicely create this new string for me. So that's called string interpolation. I can also do string interpolation slightly more precisely by using a dictionary, because then I can actually specify. Now it's just using the sequence. So the first placeholder gets the first element of the tuple, and the second placeholder gets the second tuple, and so forth. I can also specify a number. That's a D for decimal, and then I can also add a number over here. And then that placeholder there gets replaced by that number over there. But let's say I want to be a bit more specific, and then we're going to give this variable a name and call it the quick brown quick animal jumps over the lazy animal. And in this case, string interpolation would appreciate a dictionary and not a tuple. So in this case, the order is not important. Let's try something different. It's a dictionary, so it gets curly braces. There we go. Quick brown crocodile jumps over the lazy canary. What's nice about this is that I'm now I can now specify the variable that should be replaced by name, so not by sequence. So it's a bit harder to make mistakes. And it often also happens that you get dictionaries from, for example, JSON decodings or other APIs or other data representations. Okay, so that was a string interpolation with a string interpolation using a dictionary instead of a tuple. Okay, so we're going to try and put all of this together. I've tried to find a nice example for us to play with, and I arrived at the Open Weather Map Weather API. And there I found a URL that we can use to get information or to get the weather forecast for any place in the world. So I'll just show you what that looks like. Let me get the URL from over here. So I'm going to open up, as you can see in the URL bar, this is what I found. So this is an open API, and by giving it this URL with the city where with the city I live in, and the country code, and then what format, we're going to use JSON for this. And we want metric units because I'm used to degrees Celsius, and I would like to forecast for 7 days from now. So you can see the data comes back in this JSON format, and we're going to try to turn all of this into a nice graph with a 7-day weather prediction in Delft. Okay, so let's just take that same URL and start experimenting. This is how you usually do it in Python. So I know I'm going to need the URL lib 2, and then I need URL open, and in this way I can get Python to load that URL. I know it's going to return some kind of file object, and because I specified JSON, I know it's going to be a JSON file object. So let's just give it that name, and it's JSON, so I'll probably need to decode it somehow. Fortunately, Python has JSON. Let's just do that once. It takes a while. Okay, so let's see what happens now. I want JSON, and this is kind of convention in Python. I can obviously do dot and then tab and to see what happens here. It's a kind of a convention that usually these are called dump and dump s and load s. I could probably have used load. Let's just see what that wants. I press tab here to get more information. Ah, look, it can take a file object, so I'm all done almost. So let's decode that into JSON. And this will probably give me some, well, it usually gives me some kind of dictionary. Let's just call that weather dict. And I can just put the variable on there. I don't have to use an explicit print statement, because then IPython is going to print it nicely for me, which is exactly what I want. Okay, so just to reiterate, I could have done this, but then I get, let's say, a not as pretty representation. And if I just output the data variable, the last data variable that you output, that's the one that IPython will pretty print. So I can see what's happening here. It's giving me Delft back in the Netherlands. So I get this information over there. And then there's the count. I specified 7 days. It's giving me a list back. And in this list, I can find, for the 7 days, I can find all of the weather info. That's pretty convenient. Okay, let's make a new window. And I can reuse my weather dict. Remember, it's a dictionary. Just look at it again. And a dictionary, as you remember from the previous part of this tutorial, I can access like this by giving it the key. So if I give it a list, I now get list as a key. I now get out a list with 7 entries for the 7 days that I requested. So let's continue with this. This is the nice thing about Python in general, and specifically the IPython Notebook, is that I get to introspect objects like this to see what they look like and what they work like. So I can see here I'm interested in at least the rain, so it's probably millimeters of rain, the wind speed, and I'd also like to know about the minimum and the maximum temperature. So I'm planning to go somewhere this weekend. It would be nice to get some kind of prediction of the weather, and what better way to do that using an IPython Notebook and using Python to access this weather API. Okay, so now I know more or less what to expect. So now I'm going to write a function using list comprehension and using slicing as well to draw a nice weather graph. Okay, let's see what happens. So I know I'm going to use all of this. I'm using datetime, or I'm importing datetime, because I'm probably going to need that to be able to also specify which day of the week. I need to know what day today is, so I can say, you know, what the weather forecast, what days that's applicable to. So it's a new function. That's why I'm using def and giving it a function name. I would like to be able to specify a different city and a different country code, and I'd also like to specify the number of days. Okay, so now I'm going to use that string interpolation we talked about, or I showed you. I'm going to use the same URL over here. There we go. Copy paste, or at least copy first and then paste. Okay, so I'd like to replace here the city name. I'd like to replace the country code, and I'd like to replace the number of days. With string interpolation, I'm going to use a tuple for this because this is quite predictable. I just need these 3 variables. So just city, country code, and num days. There we go. So what's happening here is I'm taking the string, and based on these variables, these parameters that the user will pass my function, I build up a new URL with the relevant city, country code, and the number of days of forecast. You'll see that for city and country code, I use %s because they're both going to be strings. And for the number of days, I've used %d because it's going to be an integer, a number of days. Okay, so let's do the same what we did up here in a little experiment. So we want to do something like, there we go. We have the URL. So first we have to open it using URL-lib, like that. And then we get JSON, as you could see here when I just open up the URL. This is all JSON encoding. So we have to now decode the JSON. There we go, giving us that weather dictionary. And you'll recall that the weather dictionary contain a list, and that list contains the same number of elements as I specified in num_day. So in this case, by default, it will contain, well, if I call this with 7, it will contain 7 elements. Okay, so what we're going to do now is we're going to use a great big list comprehension to pull out the minimum temperature, the maximum temperature, the rain, and the wind speed. Okay, so I've prepared some of this for you. Oh, that didn't go so well. There we go. Okay, so let's just analyze this list comprehension. So it always is enclosed in these square brackets, this outermost square brackets. And in this case, where in my previous list comprehension, I just had word, or word.upper, in this case, I'm returning a whole tuple. I can do that. So I'm returning a tuple. The D is a dict because I'm going for D in wdict list. Now remember that wdict list was a list of dictionaries. It's all nested, right? Because when I look at wdict list, I can also, for example, show you that has 7 elements. And looking at a single element, the first one, that's a dictionary. Okay, so that's what this for D in wdict list is doing in my list comprehension. So it's going to iterate through that list, and every time I'm going to examine D like I did here. So here I could, for example, have said, so give me for that specific day dict, for that day, give me temp. So temp is itself also another nested dictionary, and for that give me the minimum temperature. So the minimum temperature for today was 16 degrees. Okay, so I'm going to do that for the minimum temperature, for the maximum temperature. And here I'm doing a little trick. So what happens when I specify something in a dictionary that's not there? I get a key error. So one way of getting around this problem is saying, well, I'm going to use get with the default value. What's going to happen there is, if that key exists in the dictionary, it'll give me its value. If not, it'll give me my default value. So look, when I specify a key that does exist, I get 16 degrees. If I specify an incorrect key or something that does not exist, I get my default value. Now I know, because I played around this dictionary before I started, that the rainfall is only noted when there was actually rain. So I use get, and if there is rain, I will get the number of millimeters. If there's no rain, I'll get 0, and that's exactly what I want. So I also extract the wind speed from that dictionary. So this TDR, let's have a look at TDR. What does it look like? Let's do that IPython trick. It's inside a function, it's not going to work. So we have to, I have to call it, obviously. TDR, so let's do that. Plot weather forecast, and let's try Delft, NL, and the number of days. See what happens. Oh, there we go. Look, so I get a new list with as many tuples as there are days, and each tuple consists of 4 elements: the minimum temperature, the maximum temperature, the rainfall, and the wind speed. Okay, so we're looking good. So now we're going to use that slicing again to be able, well, let's just plot it first so you can see what the problem actually is. There we go. So let's just plot. So first we need a list of x values. So let's just do that from 0 to right before the number of days. So if I specified 7 days, it'll go from 0, which is the day, to 6, which is 7 days from now, or at least, well, yeah, 6 days if you're technical. And then I go plot days and TDR. Now matplotlib is clever enough to know that each of these 4 values per day is to be a separate line graph. Let's just see what that looks like. Hey, look, we're getting somewhere. I don't know what's what yet, but I have temperature probably around here, and I have wind speed and rainfall probably around here. But it's a bit inconvenient that it says day 0, day 1, day 2, day 3. So I know that day 0 is Tuesday. It would be nice if it could actually plot those. And we're going to use a nice slicing exercise to be able to do that. Okay, so first we need a list of the days of the week. Starting at Sunday, because that's usually the 0th day. And then we have to figure out what today is. Now that's where daytime comes in. So you'll see if I, for example, let's just test this. That's 2. So it's Tuesday today. So if Sunday is the 0th day, and then 1 is Monday. No, wait, hang on. Yes, that's correct. 0 is Sunday, 1 is Monday, and 2 is Tuesday. That's correct. Okay, so now we've got the day, and now we need to use this information to slice up this list so that today will start at Tuesday, and then the list will run Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Oh, hang on. And then the list will run Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday. And if we can do that, we can plot that down there, and everybody will be happy. Okay. So because you know slicing, this is easy. Day words. So we just do day words, and then starting today, which in this case is 2, going to the end of the list. Well, sorry, like that. We just don't specify it. And then we make a new list also by slicing, going from the start of the list. So we just omit the start number today. And now you see why one more reason why it's convenient that Python always misses the stop element. So it's going to include day in this case, but it's going to exclude it in this case, which is exactly what I want. So I get a new array, and that should work out. Let's see what happens. So I tell matplotlib that for these days that I gave it, it should use these day words instead. See what that looks like. Control Enter. Look, not too bad. So Tuesday, that's today. Wednesday, Thursday, Friday, Saturday, Sunday, Monday. Great. This will work any day of the week that you run it. Just make a legend. And let's also give it a grid. There we go. We have a nice plot of the weather in Delft. Cool thing is I can now go and, for example, also find the weather in London. There we go. So London is looking a lot better than where I am at the moment. Look, the temperatures Wednesday, Thursday above the 20s. I should really put my legend somewhere else. No, maybe top left is better in this case. Oh, I didn't like that. Upper left. There we go. So in London, it's looking very nice. So on Saturday it will become almost 25. On Sunday, 25. Okay, so that was it for today's lesson. It was a bit longer than I'd hoped, but I hope that you liked the example. Just to summarize, we looked at the Zen of Python. This is something that you should read and absorb. We also looked at how to make Python 2.7 behave more like Python 3, also in terms of integer division. We looked at the different ways of slicing an array. You can go through this example. All of these notebooks are on GitHub, so you can download and play with them. We saw that strings are just lists, so we can use the same manipulation or same slicing on strings as well. And then we went and turned a string into a list of words, and based on that I could show you what a list comprehension looks like. That is a very compact way of combining a for statement and also an operation and a sequence in a single statement. We looked at a string interpolation. That just means that you can use placeholders and then have variables to fill in those placeholders. And you can do this either with positional arguments in a tuple, or you can do them with keyword arguments in a dictionary. And both of these have their uses. And then we used all of this information to extract data, or to get data from an open weather API in JSON. And then in the process, you also saw how one can very easily go about downloading JSON data, decoding that JSON data into a dictionary, and then pick apart the dictionary for the little pieces of data that you want. And then we also used, again, slicing to be able to make a pretty plot of the weather in any city of the world today. So that was for today. Thank you very much for tuning in.